Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to solve systems of equations and determine the number of solutions, and how to mentally visualize the graphs of functions to understand their solutions. How are we learning it? Through the systems of equations notes and systems of equations assignment. When can we use this information? To find economic solutions to financial problems such as income versus expenses and supply versus demand. And to determine how to run a successful company by utilizing the principles of supply and demand and production costs. How do we know we learned it? By getting a score of 4 on the Systems of Equations assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Systems of Equations notes, and then I'll give you time to complete the Systems of Equations assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Reasoning About Statement Study Guide and any incomplete assignments that you may have. Let's take a look now at the Systems of Equations notes. The notes begin with the learning goals and success criteria. Now, most of the time in the past, when you've done systems of equations, you've probably really only looked at it with linear equations. But these can come in any form. We can have a system of any type of equation. So the different types are linear equations, exponential equations, absolute value equations, logarithmic equations, quadratic equations, sine or cosine equations, tangent equations, and trinomial equations. So a linear equation, first of all, looks like this: y equals mx plus b, and it forms a straight line. So it should look something like that. Exponential equations come of the form y equals a times b to the x, and it forms this curved shape like this. Absolute value equations come of the form y equals a times the absolute value of x plus b, and it forms this V shape. Logarithmic equations look like y equals log of a, and it should look like this, some kind of curve like this. Notice the difference between a log equation and an exponential equation is that the asymptote for a log goes vertically, and the asymptote for an exponential function goes horizontally. Quadratic equations. Quadratic equations look like y equals a times x squared plus bx plus c. And when I graph it, it forms a U shape. Sine and cosine come of the form y equals sine x or y equals cosine x. And it forms this oscillating up and down shape. Tangent comes of the form y equals tangent x. And it forms like this snake looking thing here. So it starts like this, curves, and then goes back up. Trinomial equations look like ax cubed plus bx squared plus cx plus d, or it can look like this: y equals x plus a times x plus b times x plus c. And that's going to look like this, where it goes up, changes directions, and comes down. It almost forms like two different parabolas. So that's a trinomial equation. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click Start the Activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the Systems of Equations assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here that will take us to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. Go ahead and click Start the Activity. The activity begins with the learning goals and success criteria. We'll go ahead and click Next. And it says, consider the equation 2x plus y equals 5. if possible, find a second linear equation to create a system of equations that has, in this case, one solution. So if we want something with one solution, we know that it just can't have the same slope. So as long as it doesn't have the same slope, we should end up with exactly one solution. So let's just change the slope to x. So x plus y equals 5. That should give us exactly one solution. Now two solutions. So if we wanted two solutions, now we need to be able to have something that's going to cross in two places. Well, we know that in order for it to cross in two places, it can't be linear because it has to go through and then come back around. So this is not possible. Now what about infinitely many solutions? So in order for it to have infinitely many solutions, it needs to have the same equation for the line. So we could just type that in again. 2x plus y equals 5. And to have no solutions, they have to be parallel. So we would need the same slope but with a different y-intercept. So let's go ahead and do that. We can type this in. We know that we're going to have a slope of -2/5 once we moved everything away from y. So we just need to make sure we keep that. So y equals -2/5 x. And we just need a different y-intercept, so we can just make it +1. And that would do the trick. So now for this one it says take the same thing, but now we want something that's non-linear. So we want something with two solutions. So we could do something like y equals x squared, right? Because it's going to form a parabola, so it's going to go down and back up. So we'll have at least two solutions. Now what if we wanted three solutions? Now for some of this, you may not know all the answers. Try using Desmos and try plugging in different things to see what we can do to make this work. So let's try it. So if we go to our Desmos calculator and we type in y plus x equals 1, now we want something that's going to touch in exactly 3 places. So let's see if we can figure out how to make that work. So what if we did x minus 1, right? That's perfect because now if we can get it to change and come back down, we'll be in good shape there. So we need our other ones to be over here somewhere so that they pass through. So let's go ahead and do x minus or plus. So let's go ahead and do x plus 6. So now we're touching in 2 places. Now let's try a third, x minus 5. So now we're crossing through in 1, 2, 3 places exactly. So that's how we can do that. So we would just go ahead and enter this in. Now we want one with no solutions. So let's figure out what we can do there. What if we went with an absolute value? So remember, absolute values form a V. So if we just make it go downward, we can make this not cross at all. So if we go y equals, let's try absolute value of x. Okay, and we want it to be negative. And notice this stays parallel to this one, so we actually never touch. So this would be a possible solution. So we can plug that in here. So now it gives a scenario about Mary, how she solves this system of equations, and it asks, is it okay what she did? So you're just going to look at her steps and then decide whether it's okay what she did, and then give a reason why. Then we'll go to the next one. So for this one it says, think about the graphs of each of the equations. Explain why the systems have no solutions. Try to think about the graphs without actually graphing them. So we don't want to graph them. We just want to think about what the graphs look like. And maybe you need to graph them. So let's go ahead and try it for the first one. So the first one is y equals log base x. So let's go ahead and copy that and bring it over and paste it in here. So we have y equals log x. So that's what the graph looks like. Now the other one, we will copy this one now and go ahead and paste it. And notice, because we lifted this up here, it's never going to actually cross the other one. So on this, we're going to state why this isn't happening. Well, we can say that the log base x only exists just below mostly below the x-axis, and then over here it only extends above to about 1, right? It barely exceeds 1. This one starts above 3. So we can go ahead and put that into words and state that. So you're going to do that for each of these. And then when you're done, you're going to go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.